All right, ready to dive deep. Today, we're getting into boilers.
Ooh, fun.
Yeah, we've got this awesome guide to how they work and how to keep them, running. We're going to learn about the safety stuff, how to keep them from blowing up,
Yeah.
and all sorts of other cool things. So,
It's more exciting than you might think.
yeah, it is. So when I think about a boiler, I'm picturing this giant metal tank with steam hissing out of it. Am I close?
Yeah, you're on the right track. It's basically like a closed container where you heat water to make steam,
Okay.
and that steam can then be used to power things, or heat buildings.
So it's not just boiling water, it's about using the steam for stuff.
Exactly. And there are different types, like this guide talks about water tube and fire tube boilers.
Okay, so water tube.
So water tube, the water flows through these tubes that are surrounded by hot gas. It's like almost like a network of veins, carrying the water through the heat.
Okay, that makes sense. So fire tube.
Fire tube is the opposite. Yeah.
Yeah.
The hot gases are going through tubes that are, submerged in the water.
Got it. So safety. I mean, we're talking about superheated water steam. That's got to be a big deal.
Huge. Yeah. Safety is like the number one thing when you're dealing with boilers. And this guide talks about all kinds of safety devices: pressure gauges, alarms, safety valves.
So it's like they've got their own security team.
Yeah, exactly. Each of those things has a specific job. Like the pressure gauge, it lets the operator see, how much pressure is building up inside.
Okay. And what happens if the pressure gets too high? Like, does it just start whistling?
Well, that's where the safety valve comes in. It's like the emergency release valve. If the pressure gets too high, it automatically pops out it and lets some steam out.
Okay, so it's like a pressure cooker, but a lot more intense.
Yeah, exactly. And if you ignore these safety systems, well, let's just say things can get pretty explosive. This guide actually has a whole section on how to blow down the boiler.
Blow down the boiler. What does that even mean?
It's basically releasing a little bit of water from the boiler to get rid of, gunk that can build up in there.
Oh, okay. So it's like a cleanse for the boiler.
Yeah, kinda. You wouldn't want to drink water with all sorts of stuff in it, right?
Right.
Same with boilers. All that stuff can make it work worse and even damage it.
Wow. So are we talking like a full water change?
Not quite, but it does kind of lead us to water treatment. It's a really important part of keeping the boiler running right.
Okay. Water treatment. Intrigued. So are we putting a Brita filter on the whole thing?
It's a little more complicated than that. This guide mentions all sorts of tests they do on the water: alkalinity, chloride, all this stuff.
Whoa, whoa, whoa. So many tests. Why are all those necessary?
Well, each test tells us something different. Like the alkalinity test that tells us, is the water too acidic? Because if it is, it can start to eat away at the boiler.
Yikes. Okay, what about like chloride?
Chloride, that can cause problems too. Like if there's too much, it can cause these tiny holes in the metal, like the water's chewing away at it from the inside.
Okay, so each test is like looking for a specific problem.
Yep. And depending on what they find, they can tweak the water, like add chemicals or stuff to prevent those problems.
So it's like giving the boiler a custom spa day.
Yeah, something like that. Keeping that water in tip-top shape is really important.
Wow, it's way more complex than I thought. So we've talked about keeping it safe, keeping the water clean. But what about actually running this thing? Is it just like flipping a switch?
Oh, no, there's definitely a process to it. You can't just suddenly blast it with heat or shut it off cold.
Okay, so there's an art to it.
Yeah, you could say that. Like when you start it up, you got to do it slowly, gradually warm up the system. And shutting it down, there's a whole sequence of steps to follow, closing valves and stuff.
Like a delicate dance.
Exactly. There's even this thing in the guide about cracking open valves. It's all about controlling the flow of everything really carefully.
I love that. These little details make it so much more real.
It's pretty fascinating, right?
It is. So, okay, say I'm the boiler operator for the day. Got my safety checklist, got my water treatment plan. I know how to turn it on and off. What happens if something goes wrong?
Ooh, good question. This guide actually has a whole troubleshooting section.
Oh, nice.
Yeah, like, the water level gets too low, or there's a problem with the fuel, or one of those safety valves goes wonky.
So it's like a detective handbook for boiler operators.
Exactly. And for each problem, it gives you, possible causes, things to check first.
That's super helpful. But I'm guessing there's got to be a limit to what a non-expert can handle?
Oh, for sure. Some things you need a qualified technician for.
Right, so knowing when to call in the pros is important too.
Big time. And that actually kind of goes hand in hand with the whole inspectional and maintenance thing. You can't just, install it and forget about it.
Right, like a car, you got to keep up with it.
Yep. The guide talks about, checking for damage, testing those safety devices, making sure nothing's clogged up.
So regular tune-ups.
Yeah, basically. Prevents big problems later on.
Okay, that makes sense. Now, what about corrosion?
Oh yeah.
That's kind of scary.
It can be. Basically, it's when the metal starts to, deteriorate, like rusting, but from the inside out.
Oh, okay, so it's like the boiler is slowly dissolving.
Yeah, kinda. If it gets bad enough, leaks, cracks, even explosions.
Okay, now I'm terrified of boilers.
But that's why inspections are so important. You catch it early, you can usually stop it.
So, like going to the dentist for regular checkups.
Exactly. A little preventative care goes a long way.
Speaking of things, we were talking about low water levels earlier.
Right.
That's another thing that can go wrong, right?
Oh, yeah, super important. You got to keep the water level just right.
Goldilocks and the boiler.
Huh, pretty much. If it's too low, the boiler can overheat.
Bad, right?
Very bad. But if it's too high, well, then it can't make as much steam.
So finding that sweet spot is key.
Yep. That's why they have all these systems to monitor it, like a gauge glass. It's basically like a big see-through tube so you can see the water level.
Like a giant dipstick for the boiler.
Yep. And newer ones have these fancy electronic sensors, too.
Wow, there's a lot more tech in there than I realized.
Oh, yeah. And speaking of tech, let's talk about insulation.
Wait, insulation? Like for houses?
Yeah, but also for boilers. It helps keep all that heat inside where it belongs.
So it's like wrapping a blanket around a hot water bottle.
Great analogy. It keeps the heat from escaping, which means you need less fuel to run it.
So good for the environment and the wallet.
Win-win. And speaking of the wallet, fuel efficiency is another big thing.
Okay, so getting the most steam for your fuel, basically.
Exactly. And it depends on a lot of things. What kind of fuel you're using, how well the boiler is maintained, and something called combustion control.
Okay, combustion control sounds complicated.
It's basically making sure the fuel is burning as efficiently as possible. You got to get the right mix of fuel and air.
So it's another delicate balance.
It is, and newer boilers have these fancy computer systems to manage it.
It's amazing how much goes into these things.
Right. It's not just about boiling water.
So much more than I ever imagined. We've covered a lot, but I'm sure there's even more to learn about these amazing machines.
Definitely. Stay tuned for the next part of our deep dive. We'll be getting into even more fascinating details.
Can't wait. Welcome back. We're getting even deeper into the world of boilers.
Yeah, we've got a lot more to talk about.
We do. Last time we talked about safety features and keeping that water clean. But I feel like we've only just gotten started.
Oh, yeah, definitely. Today, I want to talk about something that's super important for how boilers actually work: pressure and temperature.
Okay, pressure and temperature. I get that they're both involved, but how are they actually connected?
So think of it like this. You heat water, the molecules start moving around faster, like a dance party in a tea kettle. All that movement creates pressure, right? The molecules are bouncing off the walls of the boiler.
So the hotter the water, the wilder the party, the higher the pressure.
Exactly. And the relationship between them isn't like, a straight line. It gets like more intense.
More intense.
Yeah, like the hotter it gets, the pressure goes up even faster.
So a little change in temperature could mean a big jump in pressure.
Exactly. And that's why it's so important to, control it, keep things balanced.
So it's like walking a tightrope. Too much pressure, not enough.
Yeah. If the temperature gets too high, boom, pressure spikes, could be dangerous. But if the pressure's too low, you don't get enough steam.
So how do they keep it all in check?
Technology, mostly. Pressure gauges, temperature sensors, all feeding into this control system that's like the boiler's brain. It keeps everything running smoothly.
Like they have a little team of observers watching over them.
Yeah. So speaking of things you might not think about, insulation.
Wait, insulation, isn't that for like houses?
For houses too, but for boilers as well. You don't want all that heat escaping, right?
Right.
It's like wrapping a blanket around the boiler to keep all that heat in.
The less wasted heat, less fuel you need to burn.
Exactly. Good for the environment, good for your wallet, everyone wins.
So what kind of insulation are we talking about here? Like pink, fluffy stuff?
It depends. Fiberglass, mineral wool, sometimes even these special ceramic fibers if it's really hot.
Wow, it's a whole science.
It is. So now let's talk about something called accumulation pressure. Sounds intense, right?
Accumulation pressure. It does. What is that?
Remember those safety valves we talked about? They prevent the pressure from getting too high?
Yep, the emergency release valves.
Right. But even those can have pressure build up in them. That's accumulation pressure.
So it's like pressure on top of pressure.
Exactly. It's from the spring inside the valve pushing back against the boiler pressure. It stores energy.
Okay, I think I'm following, but why is this important?
Because if it gets too high, the safety valve may not work properly, like something's weighing it down.
Oh, wow, so it could actually make it less safe.
Yeah, that's why they have a special test for it, to make sure the valve can still open when it needs to.
So it's like a checkup for the safety valve.
Yep. Now let's shift gears and talk about water treatment again.
Okay, we talked about how impurities can be bad.
Right. We got to control the chemistry of that water. Like, the guide talks a lot about pH.
pH, back to chemistry class. What's that all about again?
Basically, how acidic or basic the water is. The scale goes from 0 to 14. 7 is neutral. Lower than that is acidic. Higher is basic.
Okay, vaguely remember that. But why is it so important for boilers?
Well, different pH levels affect the metal differently. Too acidic, and it can corrode, like acid eating away at it. Too basic, other problems pop up.
So got to find that Goldilocks zone. Not too acidic, not too basic.
Exactly. The guide recommends keeping it slightly basic, around 10.5 to 11.5.
How do they actually adjust it, though?
Chemicals, they add different things to the water to tweak the pH and keep it in that sweet spot.
Okay, that makes sense. What about the other stuff in the water, the impurities that can clog things up?
Great question. The guide actually talks about something called liquid WT solution.
Liquid WT sounds like some kind of high-tech fuel.
Not fuel, but it is pretty cool. Basically, under all that pressure and heat inside the boiler, the water changes a bit. The impurities actually separate out and settle at the bottom.
So it's like they naturally filter themselves out.
It's not a perfect solution, but it helps. Then they can remove that stuff through blowdown. Remember that.
Right, so it's another layer of protection.
Exactly. Now let's talk about the folks who keep all this running, the maintenance crew.
Maintenance, what's involved with that?
Well, regular inspections are key. They got to check for leaks, corrosion, make sure all the safety devices are working.
So it's like a full-body checkup for the boiler.
Yep. And some things get extra attention, like the gauge glass that shows the water level. Got to make sure that's clean and accurate.
Makes sense. What else do they check?
The furnace, where the fuel burns, is another big one. They check the lining to make sure it's not damaged, inspect the burners.
Like they're looking for clues.
Haha, yeah. And then there's preventative stuff, too, like cleaning the tubes, lubricating moving parts, checking electrical connections.
Sounds like a lot of work.
It is, but it's worth it. Keeps things running smoothly, prevents breakdown, and keeps everyone safe.
So a little effort up front saves a lot of trouble later on.
Exactly. Now, the guide also mentions different types of boilers. There are composite boilers, alternative boilers, and economizer boilers.
Okay, let's break those down. What's a composite boiler?
A composite boiler uses more than one type of fuel.
So it's like a hybrid car, but for boilers.
Yep, you can switch fuels depending on what's available and how much it costs.
That's pretty smart. What about alternative boilers?
Alternative boilers are used in special situations, like say you have a factory that makes a lot of waste heat. You could use an alternative boiler to capture that heat and use it to make steam.
So it's like recycling energy. What about economizer boilers?
Those are all about efficiency. They capture waste heat from the exhaust and use it to preheat the water going into the boiler.
So they're basically getting free heat. That's awesome.
It saves fuel and money. So as you can see, there's a whole world of boilers out there.
It's fascinating. We've talked about them a lot, but I think those safety valves deserve another look.
Oh, for sure. They're crucial.
I know they're like the last line of defense, but why are they so important?
Well, a boiler is basically a giant pressure cooker, right? As the water heats up and turns into steam, the pressure keeps going up. If it gets too high, boom.
That's where the safety valve comes in.
Right. It opens up and lets some steam out, preventing a disaster. They have to work perfectly, so they get tested and inspected all the time.
What kind of tests do they do?
One is called a lift test, where they actually make the valve open to make sure it moves freely. And there are pressure tests, too, to make sure it opens at the right pressure.
So it's not just about having a valve. It's got to work properly.
Exactly. And they need maintenance, too. Cleaning, inspecting, replacing parts.
Wow, they really take those safety valves seriously.
They have to. A bad safety valve could cause a major disaster. Now, here's a question. Why do boilers often have two safety valves?
Two, why not just one big one?
Well, having two means if one fails, the other one is still there as backup.
Ah, redundancy. Like having a spare tire?
Exactly. That two smaller valves are actually better than one big one. They're faster, easier to install, less stress on the boiler.
So it's safer, more efficient, and more practical.
Yep. Now let's talk about corrosion again.
Okay, corrosion we talked about with water treatment, but how big of a problem is it really?
It's a constant battle, especially around salt water. The guide talks about all sorts of different types.
Different types? I thought it was just rust.
There's erosion corrosion, where the flow of water or steam wears away at the metal, and direct chemical attack, where certain chemicals in the water react with the metal and eat it away.
Okay, that one sounds scary.
It is, and then there's electrochemical corrosion, where different metals in the boiler actually create a tiny battery.
A battery inside the boiler.
Yeah. One metal corrodes, the other is protected, all thanks to the water acting like an electrolyte.
That's wild.
So you can see why preventing corrosion is so important. It can really mess things up.
So how do they prevent it?
It's a multi-pronged approach. Good water treatment is essential, and regular inspections are key to catch it early. They also use special materials that are resistant to corrosion.
So it's like a combination of good habits and a strong immune system.
Exactly. And speaking of things that can weaken a boiler's immune system, let's talk about explosions.
Explosions.
It's a real danger if corrosion gets out of hand. One thing the guide talks about is oil buildup in the furnace.
Oil. How does that get in there?
Sometimes small amounts leak in from the fuel system or lubricants. If it builds up, it can mix with the air and become explosive.
Like a ticking time bomb.
Pretty much. A spark or flame could set it off. That's why they regularly inspect the furnace and clean out any oil they find.
Wow, so important.
Definitely. Now let's talk about something called hydraulic pressure testing.
Okay, sounds intense.
It is. Basically, they fill the boiler with water and then pump it up to a super high pressure, way higher than normal.
They're purposely trying to break it?
Haha, not exactly. It's a controlled test to see if it can handle the pressure. If it passes, they know it's safe to operate.
So like a super intense workout for the boiler.
Yep, it's all about safety. This deep dive has really opened my eyes to how complex these machines are. They are amazing feats of engineering.
We've learned so much, but there's still more to uncover. Stay tuned for the final part of our deep dive, where we'll tackle even more fascinating aspects of boilers.
It's going to be steamy.
Back again for the final round of our boiler deep dive.
We saved the best for last.
Seriously, we've talked about so much already. Safety, water treatment, corrosion, that pressure-temperature dance.
But we've got more. Today, I want to talk about something that can really mess with a boiler's efficiency.
Soot. I always thought of that as just like messy taxes. Is it really that big a deal?
It might seem like just a nuisance, but it can cause some real problems. Soot is a really good insulator, which is great for some things, but not for boilers.
Wait, so what's good at keeping things warm is bad for a boiler? How does that work?
Think of it like this. When soot builds up on the inside, it blocks the heat from getting to the water.
Oh, okay, so it's like putting a layer of, I don't know, a blanket between the fire and the pot.
Exactly. And that means the boiler has to work harder, burn more fuel to make the same amount of steam.
So not very efficient.
Not at all. And it can cause other problems too, like overheating.
Overheating, that sounds bad.
Yeah, too much heat can warp the metal, even cause cracks. In extreme cases, it could even make those explosions we talked about more likely.
Okay, soot is officially on my bad list now, so how do they get rid of it?
One way is with a soot blower. Basically, they blast steam or air through the boiler to knock the soot loose.
So it's like a power wash for the inside of the boiler.
Yeah, pretty much. There are also manual methods, like using brushes and scrapers.
I bet that's a dirty job.
It is, but it's got to be done. Now, speaking of efficiency, there's this thing called boiler efficiency testing.
Boiler efficiency testing. Sounds fancy.
It's basically a way to see how well the boiler is turning fuel into heat. They measure how much energy is being wasted.
So it's like a report card for the boiler.
Haha, kinda. And it helps them figure out how to make it run better.
So what kinds of things can they do to improve efficiency?
Well, we talked about combustion control before. Making sure the fuel burns properly is huge, but there's also insulation, minimizing blowdown, preventing heat loss.
So it's like fine-tuning a race car.
Yeah, it's all about getting the most out of it, and technology is always improving, so there are always new ways to make boilers even better.
This whole deep dive has been amazing. I never realized how much goes into making these things work.
It's pretty fascinating stuff, right?
It is. I'm definitely looking at steam a little differently now. To all our listeners out there, we hope you've enjoyed this journey into the world of boilers.
Keep those boilers steaming.